Okay, everybody, this is section 11.3. It's surface area of pyramids and cones. This one has some unique pieces that we need to find for our formula that we have for this particular one. A pyramid and a cone basically are doing the same thing, kind of like a prism and the cylinder that we had in section 2. Using basically the same formula for two different figures. Okay, so we got definitions for this on top. I'll pull them out if you want to hit pause and write them down, and then we'll get going. So for a pyramid, it's a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex. A regular pyramid is going to have a regular polygon for a base, and its height meets at the center. Okay? And slant height is the length of the oblique lateral edges. What the heck is oblique? That's going to be the slant thing that will be a face that meets at the top. That's what kind of creates a pyramid. So let's label this. A regular polygon is going to have to have a vertical height. So that's going to be here. And what we could do here is draw in a right triangle with the height half of the base, okay, half of the base, and then this lateral height, so the letter L. That lateral height goes from the center of a side, the base, and kind of bisects all the way up to the top. So this creates a right triangle. So sometimes we give you the height, but in our formula we need this lateral height. Okay, so I can use typically Pythagorean theorem to be able to do that. So just write that down. Make sure you understand that I've created a right triangle with this thing on the inside of the pyramid. I might need to use Pythagorean theorem because most of the time I need that lateral height. Okay. The base could be like this is probably a square base here. We are going to deal with one that has a hexagon base, so we're going to have to use, our apothem and perimeter and that formula too. So just when we get there, I'll show you. Okay. Unfortunately, we kind of start off with a pretty difficult problem just because of the numbers that are involved here. Okay. So let's go ahead and do this. First off, I'm going to assume that the base is square. They only give me one value, so I'm going to assume that all of these sides are the same. Okay. And if you look at the box just below this figure, it gives you the formula. So we'll do that now. The area of the formula is going to be half of the. I'm sorry, I'm getting ahead of myself here. It's going to be the area of the base plus half of the perimeter of the same base times the lateral height. Okay, and to be honest with you guys, I kind of do this for this piece right here. Okay, whatever you want to do. That's typically what we're going to do anyways. Okay, so I still am going to need the area of the base for this one. I'm still going to need the perimeter of the base for this one. So similar to what we did with the cylinder and with the prism, okay? But I do need the lateral height, and if you remember our definition we just did, this is my lateral height, and I don't have it, okay? But they did give me the vertical height, so if I did this and drew in a right triangle, I might be able to use it, but I got to remember that for this piece of it, it's going to be 150. It's half of what the base was, okay? So I'm going to use Pythagorean theorem to get that. But first off, I'm going to get the area of the base. That's going to be 300 times 300, and that's going to get me 90,000, okay? I need the area or the perimeter of that. So, 300 times 4 is going to give me 1,200 for my perimeter, okay? So that's just, adding up all the sides, but I'm assuming they're all the same, so 300 times 4 is 1,200, okay? Over here too, I'm going to do my Pythagorean theorem. I'm going to go 150 squared plus 321 squared, and that L is really my C in Pythagorean theorem, so L squared. All right. So if you want to hit pause, and you can do the Pythagorean theorem there and get something for L. Remember, you got to take the square root of whatever you get after you do that. Okay. So I get 90,000. Oops, I'm sorry. I get 22,000 on, let's go, 22,500 plus 103,041, okay, equals L squared. And then I'm going to go ahead and just add those, and I get about 125,541, oh my gosh, equals L squared. Okay, so just big numbers here right off the bat. It's been nicer to get a nice easy one. I'm going to go ahead and take the square root of both sides, and L is going to give me approximately 354. So that's going to be my lateral height, okay, and I'm going to use that and plug it back into my formula. Okay, so let's take this stuff, the area, the surface area of the base is going to be 90,000 plus the perimeter of the base, which was 1,200 times the lateral height, which was 354, divided by 2. Okay, so don't forget about that part. Okay. Once you hit pause and do your math, let's come back and compare our answers. And do all your math, and I got approximately 302,580, and it was in feet, so feet squared. Okay, so I'm pretty sure that's an actual surface area of an actual pyramid that exists somewhere over there in Egypt, probably. Okay. Not a fun one to just start right off with, but hey, you know, we're plugging numbers into a formula. We went and found them. I think you guys are pretty good at being able to do that, especially by now. Okay, so hopefully it didn't hurt you too much to do that one. For this one, you know, we're repeating here the formula. Once again, you know, I kind of do this for that piece. Okay. You notice that this part's a little bit different from what we did earlier because there's only one base now for a pyramid. Okay. This one though is a hexagonal based figure. Okay. They're giving me here that the side length for each side is 6. Okay. And I know that base doesn't look regular, but let's assume that it is. Okay. They also are giving me a slant height of 8, so that's kind of nice. They gave me something I had to find last time. Okay, so let's come over here and use this little figure. Now, this one on the board looks like it's regular, but in your packet it does not. Okay, but there's a regular hexagon. We're going to draw the apothem in, draw the radius in, and go ahead and show that that's right. I'm going to need the area, or I need the length of the apothem. So remember, this gets split into half, so 3 and 3. This is going to be the short leg, and I need the long leg, so I'm going to multiply that by the square root of 3, and I get that. Okay. Remember then, the area of apothem is 1/2 the apothem times the perimeter. Well, I need the perimeter, so I'm going to take this side 6 and multiply it by 6. I'm going to get a perimeter of 36, and I have the apothem. Okay, So plug that in, 3 square root of 3 times the perimeter, which was 36, and I'm going to divide it by 2. Okay, and I went and 3 square root of 3, I think I multiplied that out and I rounded it to 5.2 and multiply that to 36. And then divide that by 2, I get an area of 93.6, and that's rounded, okay? So hopefully you got a little bit of math. You know, guys, when I say go and do the math, you might want to, get in the habit of pausing it and just do it real quick instead of feeling like you're being rushed, okay? Take your time when you're doing it on your own, all right? So I've got everything. I found the area of the base. Because I found the area of the base, I had to have the perimeter, and I needed that for the other formula, so that's kind of cool. And they gave me the slant height, that was this, 8, okay? So let's go do our formula. The surface area for the pyramid is going to be the area of the base, 93.6, plus the perimeter of the base, which was 36, times the lateral height, which was 8. And I'm going to divide that by 2, okay? So if you guys want to go ahead and do your math there, hit pause and do your math, and then we'll look at our values, okay? Okay, so that hexagonal base gave me an area of 93.6, and taking the area and the slant height divided by 2 gave me 144, and add those together gave me approximately 237.6 meters squared. Okay, so we did pretty good there on that one. Go here. This is just a little extra problem, so find some a spot to work this out somewhere on your paper. But they give me everything. They give me the slant height. I'm assuming this is a square. If they only give me one value, I'm assuming that's going to be a square. So this should be pretty easy. So I'm going to let you guys go ahead and do that. Got the formula. You got what you could do to find the area and the perimeter. You got the slant height. Just take everything and throw it in there, okay? So if you want to hit pause, and then I'll put the values up here, okay? Once again, I just do this off to the side. I need to find the area of the base, so 6 times 6 is 36. I need the perimeter, so I'm going to add up all the sides. So basically 6 times 4 is going to give me 24, and they gave me a lateral height, okay? So surface area is going to be the area of the base plus the perimeter times the lateral height. In this case, it was 5, and I'll divide that by 2. Okay, so I'm going to get the surface area is going to be 36 plus, and 24 times 5 is 120, and divided by 2 is 60. And I'm going to get a surface area of 96 inches squared. Okay. Okay, so we're going to move into a cone. Everybody likes ice cream, and most of you like cones with that, so I'll get the waffle cone though. Okay, a little better. Anyways, a cone is going to be has a circular base and a vertex or a point that is not in the same plane as the base. So the point up there where it kind of comes together, and the base, you would think of those being parallel, even though we can draw a area through that, or a vertical height through that. Let me kind of move this thing. Let's do this too, just so you know. I'm going to need the lateral height again for a cone, just like a pyramid, and I can draw a vertical height straight down from the point to the center of the circle, and then out here I can get a right triangle again. And since I need the lateral height, sometimes we're jerks and we don't give it to you. You have to go find it. You can use Pythagorean theorem for that. And your L is going to be the C. Okay, so same thing as like in a pyramid. You're going to have to go find it. The formula right here is a little bit, wrote it a little bit differently. It's the same thing as we just did before. The perimeter of a circle is going to be the circumference times the lateral height divided by 2. I do need the area of the base, and the base this time's a circle, so I'm going to have to use pi r squared to get the area of the base. Remember that to be. And I am going to have to get the circumference. Remember, it's 2 pi r, or diameter times pi. And pi will be 3.14. Okay? So we're going to have a little bit of work here to get these guys. Okay? Okay, luckily we start off pretty easily here with this one. I do need the slant height. I don't have it, but I'm drawing this little triangle in here, and I can use Pythagorean theorem. Okay, so let's go ahead and do that first. So 3 squared plus 4 squared equals L squared. 3 squared is 9, 4 squared is 16. L squared, I'm going to get 25 equals L squared. And so L, take the square root of both sides, L is 5. Okay, so we got a piece of this formula that I need to deal with. Okay, let's go get the other 2 pieces. I got to get the area of the base, so that's going to be pi r squared. So pi is 3.14. The radius is 4. And then you can multiply that up. I'll let you guys do that. And if we get about 50.24, I'm going to just round it to 50.2. Okay. I'm also going to have to get the circumference of that. So I'm going to get 2 times pi times the radius. The radius was 4 again. And that should get you about 25.1. Okay, doing a little bit of rounding on both of those. Okay, so now I got all the pieces I need. I got the lateral height, the area of the base, the circumference of the base. So the surface area is going to equal the base, 50.2, plus the circumference, 25.1, times the lateral height, which we found was 5. Okay. Divide that by 2. And we do all this math. Over here, I was going to do an extra step. I believe over here I get about 62.8. Okay. And I'm going to add those together, and I get approximately 113. Sorry, this is 113.04. I'm looking at some old notes here. So about 113 if I was going to round this. Okay, so we're okay with that. As long as we're close. And feet squared, because they did give me units. Okay. Okay, so there you go there. That one. You got this one down here at the bottom. A little extra problem, so I think you have plenty of room to do this one. They're giving me the lateral height, so that was cool. They're giving me the diameter here, so my radius, I have to take the diameter divided by 2, and I get about 11.5. So I need radiuses to do the stuff I need. So let's go over here. I'm going to let you guys do this problem. So, find the area of the base, get the circumference. You got the lateral height here. So you're pretty much good to go. I gave you the radius right here. Okay, so why don't you guys hit pause and go ahead and try this one, see how you do, and I'll put it up. Okay, so over here on the left, I got the area of the base. base and multiplied that out, and I got about 415.3. For the circumference, I got about 72.2. Okay, we go ahead and plug that in. So my area of the base is 415.3 plus the circumference, which was 72.2. Multiply that by the lateral height, which is 14, and divide that by 2. Okay, so doing all my math, I'll show you everything I got. And I get about 1,010.82. So 505.4. I'm going to go ahead and add that together. So about 920.7 meters squared. Okay. All right, so that was a little extra problem there at the end. Hope you guys did okay with that. And so, notice that the similarities between the two formulas we got here, pretty much the same thing, just change in perimeter and circumference. But there's only one base for a cone and a pyramid, different than the prism and the cylinder we did before. Okay, so you got to try to keep these separate.